What if the key to humanity's survival isn't on Earth, but hidden among the stars? Picture this, a future where we're not just visitors to space, but permanent residents, exploring worlds we once thought were beyond our reach. This isn't science fiction, it's the reality being shaped by 15 groundbreaking space missions that could redefine everything we know about the universe, technology, and even life itself. From peering into the origins of the cosmos to uncovering the secrets of distant moons, these missions are pushing the boundaries of what's possible. They're not just about discovery, they're about transformation. Imagine a world where we harness resources from asteroids, establish colonies on the moon, and search for life on Mars. These missions could change the way we see ourselves, our planet, and our place in the cosmos. So, buckle up, because today we're diving into the 15 space missions that could change everything. By the end of this journey, you'll see the universe in a whole new light, and you might just wonder if humanity's greatest adventures are still ahead of us. Let's begin. Now turning to the first of these groundbreaking missions, let's explore the James Webb Space Telescope, a marvel of modern science that's already reshaping our understanding of the cosmos. Unlike any telescope before it, the James Webb Space Telescope uses advanced infrared technology to see through cosmic dust and peer deeper into space than ever before. This allows it to capture light from the earliest galaxies, giving us a glimpse into the universe's infancy just a few 100 million years after the Big Bang. But its capabilities don't stop there. The telescope is also a game-changer in the search for exoplanets, planets orbiting stars outside our solar system. By analyzing the atmospheres of these distant worlds, the James Webb Space Telescope can detect chemical signatures like water vapor, methane, and even oxygen, key ingredients that could hint at the possibility of life. Already, it has made headlines with stunning discoveries, from detailed images of star-forming regions to the detection of carbon dioxide in an exoplanet's atmosphere. These findings aren't just scientific milestones, they're stepping stones toward answering some of humanity's biggest questions. Are we alone in the universe? How did galaxies form and evolve? And what secrets lie hidden in the farthest reaches of space? The James Webb Space Telescope is more than a tool for discovery. It's a window into the past, present, and future of the cosmos, and its revelations are only just beginning. Now turning to the next frontier of the James Webb Space Telescope's mission, let's delve into its groundbreaking potential in the field of astrobiology, the search for life beyond Earth. One of the most exciting capabilities of this telescope is its ability to analyze the chemical compositions of exoplanet atmospheres with unprecedented precision. By studying the light that passes through these atmospheres, the James Webb Telescope can detect key biosignatures, chemical markers that might indicate the presence of life. For example, the presence of oxygen, methane, or even water vapor in an exoplanet's atmosphere could suggest the possibility of biological activity. These findings could help us identify worlds that are not only habitable but potentially inhabited. Imagine the implications of discovering a planet with an atmosphere rich in oxygen, a gas that on Earth is largely produced by living organisms. Such a discovery would not only revolutionize our understanding of biology, but also challenge our philosophical perspectives on life's uniqueness in the universe. Are we alone, or is life a common phenomenon scattered across the cosmos? The James Webb Space Telescope is bringing us closer to answering these profound questions. Its ability to peer into the atmospheres of distant worlds is not just a scientific achievement, it's a step toward redefining what it means to be alive in the universe. As we continue to explore, each new discovery could reshape our understanding of life itself, opening doors to possibilities we've only begun to imagine. Now turning to the next chapter of humanity's journey into space, let's explore NASA Artemis Program, a bold initiative to return humans to the moon and establish a sustainable presence there. This mission is not just about revisiting our celestial neighbor, it's about laying the groundwork for the future of deep space exploration. One of the most groundbreaking aspects of Artemis is its commitment to diversity and inclusion. For the first time in history, the program aims to land the first woman and the first person of color on the lunar surface, marking a monumental step forward in representation and equality in space exploration. But Artemis is about more than just historic firsts. It's also about building the infrastructure needed for long-term lunar habitation. A key component of this effort is the Lunar Gateway, a planned space station that will orbit the Moon. The Gateway will serve as a staging point for lunar missions, providing a platform for scientific research, technology testing, and international collaboration. This orbital outpost will enable astronauts to live and work in deep space for extended periods, preparing us for the next giant leap, missions to Mars. The Artemis program is also driving remarkable technological advancements, from next-generation space suits to advanced life support systems and new lunar landers. These innovations are not only essential for lunar exploration, but will also be critical for future missions to the Red Planet. What makes Artemis truly unique is its global approach. NASA is partnering with space agencies and private companies around the world, fostering international cooperation and shared expertise. Together, these efforts are paving the way for a new era of space exploration, one where humanity's presence extends beyond Earth and the Moon becomes a stepping stone to the stars. As we look to the future, the Artemis program reminds us that the sky is not the limit, it's just the beginning. Now turning to the next phase of the Artemis program, let's delve deeper into its focus on utilizing lunar resources, a critical step towards sustaining long-term human presence on the Moon. One of the most exciting discoveries in recent years is the presence of water ice in the Moon's permanently shadowed regions, particularly near the South Pole. This water ice isn't just a scientific curiosity, it's a game changer for space exploration. By extracting and using this resource, we could revolutionize how we approach missions beyond Earth. Water can be split into hydrogen and oxygen, providing breathable air for astronauts and fuel for rockets. This means that instead of hauling all the necessary supplies from Earth, future missions could rely on lunar resources, drastically reducing the cost and complexity of space travel. But the potential of lunar resources doesn't stop there. The Moon's regolith, or surface material, contains valuable metals and minerals that could be used to build infrastructure, such as habitats and solar panels, directly on the lunar surface. This concept, known as in situ resource utilization, could transform the Moon into a hub for deep space exploration, serving as a stepping stone for missions to Mars and beyond. However, the idea of lunar mining isn't without its challenges. Logistically, extracting resources from the Moon's harsh environment requires advanced robotics and innovative technologies. The extreme temperatures, lack of atmosphere, and abrasive lunar dust pose significant hurdles that engineers and scientists are working to overcome. Ethically, the question of who owns lunar resources and how they should be used is a complex issue. The 1967 Outer Space Treaty prohibits nations from claiming sovereignty over celestial bodies, but it doesn't explicitly address resource extraction. As more countries and private companies set their sights on the Moon, establishing clear guidelines for lunar mining will be essential to ensure that space exploration remains a collaborative and equitable endeavor. The Artemis program's focus on lunar resources is not just about survival, it's about sustainability and progress. By harnessing the Moon's natural wealth, we're not only preparing for a future where humans live and work on the Moon, but also laying the foundation for humanity's next great adventure, the journey to Mars and beyond. Now turning to the next groundbreaking mission, let's explore the Mars Sample Return Mission, a bold collaboration between NASA and the European Space Agency. This mission aims to achieve something never done before, bringing Martian soil and rock samples back to Earth for detailed analysis. The significance of this endeavor cannot be overstated. These samples could unlock secrets about Mars' geological history, offering clues about its past climate, volcanic activity, and even the possibility of ancient life. Imagine holding a piece of another planet in your hands, a tangible piece of the red planet that could rewrite our understanding of the solar system. But getting these samples back to Earth is no small feat. The mission involves multiple stages, starting with the Perseverance rover, which is already on Mars collecting and caching samples. Next, a lander will deliver a fetch rover to retrieve these samples and load them into a small rocket, which will then launch them into Martian orbit. From there, an orbiter will capture the samples and bring them back to Earth. Each step of this process is a technological marvel, requiring precision and innovation. One of the biggest challenges is launching from Mars, a planet with a thin atmosphere and lower gravity than Earth. This makes it incredibly difficult to achieve the necessary thrust to escape Mars' gravitational pull. Additionally, the mission must ensure that the samples remain uncontaminated, preserving their scientific integrity. If successful, the Mars sample return mission could lead to groundbreaking discoveries. Scientists could analyze the samples for signs of past microbial life, study the planet's geological evolution, and even test technologies that could one day support human missions to Mars. This mission isn't just about bringing rocks back. It's about bringing us closer to answering one of humanity's most profound questions: are we alone in the universe? As we look to the future, the Mars sample return mission represents a critical step in our journey to explore and understand the red planet, paving the way for the next chapter in space exploration. Now turning to the implications of what could be the most monumental discovery in human history, let's explore what it would mean if the Mars sample return mission uncovers evidence of past or present life on the red planet. Such a discovery would fundamentally reshape our understanding of life's origins, not just on Mars, but across the universe. If life once thrived on Mars, it would suggest that the conditions necessary for life are far more common than we ever imagined. This would open up the possibility that life could exist elsewhere in our solar system, perhaps in the subsurface oceans of Europa or Enceladus, or even in the methane lakes of Titan. The discovery of Martian life would also challenge our understanding of biology itself. Scientists would study these organisms to determine whether they share a common origin with life on Earth, or if they represent an entirely separate genesis. This could lead to groundbreaking insights into the nature of life and its ability to emerge in diverse environments. But with such a discovery comes profound ethical considerations. If Mars harbors life, even in microbial form, we must carefully consider the impact of human exploration. Contaminating Mars with Earth-based microbes could jeopardize any native life forms, potentially erasing evidence of their existence before we even fully understand them. This raises questions about planetary protection and our responsibility as explorers. How do we balance our desire to explore and learn with the need to preserve and protect? The implications of finding life on Mars extend beyond science. They touch on philosophy, ethics, and even our place in the cosmos. It would force us to confront the possibility that we are not alone, and that life is a universal phenomenon. As we await the results of the Mars sample return mission, one thing is certain: the discovery of life on Mars would mark a turning point in human history, forever changing how we see ourselves and our place in the universe. Now turning to another celestial body that has captured the imagination of scientists and dreamers alike, let's dive into the Europa Clipper mission. This ambitious project is set to explore Jupiter's moon Europa, a world that hides a vast subsurface ocean beneath its icy shell. Scientists believe this ocean could hold more than twice the volume of all Earth's oceans combined, making Europa one of the most promising places in our solar system to search for signs of extraterrestrial life. The Europa Clipper mission is designed to study this enigmatic moon in unprecedented detail, using a suite of advanced instruments to analyze its icy surface, measure the thickness of its ice shell, and even sample the plumes of water vapor that occasionally erupt from its surface. These plumes could provide a direct window into the ocean below, offering clues about its composition and potential habitability. But exploring Europa is no easy task. The moon lies in the intense radiation environment of Jupiter's magnetic field, which poses significant challenges for both the spacecraft and its instruments. Engineers have had to design the Clipper to withstand these harsh conditions while still delivering precise scientific data. If successful, this mission could revolutionize our understanding of Europa and its potential to support life. The implications are staggering. What if this distant moon, with its hidden ocean, is home to microbial life forms? Such a discovery would not only expand our understanding of where life can exist, but also inspire future missions to explore other icy worlds, like Saturn's moons Enceladus and Titan. As we prepare for the Europa Clipper's journey, one thing is clear. This mission could bring us one step closer to answering one of humanity's most profound questions. Are we alone in the universe? Now turning to the heart of Europa's mystery, its subsurface ocean, we find a world that could hold the keys to understanding life beyond Earth. Scientists believe this vast ocean, hidden beneath miles of ice, might not only contain liquid water but also the essential ingredients for life. One of the most intriguing theories is that Europa's ocean floor could host hydrothermal vents, much like those found in Earth's deep oceans. On our planet, these vents are teeming with life, thriving in complete darkness and extreme pressure. If similar vents exist on Europa, they could provide the energy and nutrients needed to sustain microbial life forms, even in the absence of sunlight. The chemical reactions at these vents might create a habitable environment, raising the tantalizing possibility that Europa's ocean could be home to its own unique ecosystem. But how do we explore this hidden world? The challenge lies in developing the technology to drill through Europa's thick ice shell, which could be several miles deep. Engineers and scientists are already brainstorming innovative solutions, such as robotic probes equipped with advanced drilling systems or even autonomous submersibles designed to navigate the ocean's depths. These technologies would need to withstand extreme cold, high pressure, and the corrosive effects of saltwater, all while operating in complete isolation from Earth. The potential rewards, however, are immense. Directly sampling Europa's ocean could reveal not only the presence of life, but also provide insights into how life might arise in other icy worlds across the galaxy. As we look to the future, the Europa Clipper mission is just the beginning. It will pave the way for even more ambitious endeavors, bringing us closer to unlocking the secrets of this distant moon, and perhaps discovering that we are not alone in the universe. Now turning to another icy moon in our solar system, we arrive at Titan, Saturn's largest moon and a world unlike any other. NASA's Dragonfly mission is set to explore this enigmatic moon with a revolutionary rotorcraft designed to fly through Titan's thick atmosphere. Unlike any mission before it, Dragonfly will act as both a lander and a drone, hopping across Titan's surface to study its diverse terrain. What makes Titan so fascinating is its unique environment. It's the only moon in the solar system with a dense atmosphere, and its surface is dotted with lakes and rivers not of water, but of liquid methane and ethane. These conditions make Titan a prime target for astrobiology, as its chemistry resembles the probiotic conditions thought to exist on early Earth. The Dragonfly mission aims to study Titan's complex organic chemistry, searching for clues about how life might have begun on our own planet. By analyzing the moon's methane cycle, hydrocarbon lakes, and atmospheric processes, scientists hope to uncover the chemical pathways that could lead to the formation of life. But exploring Titan is no easy feat. Its thick atmosphere and extreme cold pose significant challenges for the rotorcraft's instruments and power systems. Despite these hurdles, the potential discoveries are groundbreaking. Dragonfly could reveal how organic molecules evolve in environments rich in carbon and nitrogen, offering a glimpse into the early stages of life's emergence. As we prepare for this daring mission, Titan stands as a testament to the incredible diversity of worlds in our solar system and the endless possibilities for discovery that lie ahead. Now turning to Titan's probiotic chemistry, we find a world that could hold the keys to understanding how life began on Earth. Titan's atmosphere is rich in nitrogen and methane, creating a chemical playground where complex organic molecules form naturally. These molecules, known as tholins, are thought to be similar to the building blocks that kick-started life on our own planet billions of years ago. By studying Titan's methane cycle, scientists hope to uncover how these organic compounds evolve over time, offering a window into the early stages of life's emergence. The Moon's hydrocarbon lakes and rivers add another layer of intrigue. These liquid bodies, composed of methane and ethane, are not just geological curiosities, they are active chemical laboratories. The interaction between Titan's atmosphere and its surface liquids creates a dynamic environment where organic molecules can mix, react, and potentially form more complex structures. This process mirrors the conditions that may have existed on Earth before life took hold, making Titan a natural laboratory for studying probiotic chemistry. However, exploring Titan's chemistry comes with significant challenges. The extreme cold, with temperatures dropping to -179 degrees Celsius, poses a constant threat to the Dragonfly rotorcraft's instruments and power systems. The thick atmosphere, while enabling flight, also complicates communication and navigation. Despite these hurdles, the mission's potential rewards are immense. By analyzing Titan's chemical processes, Dragonfly could provide unprecedented insights into how simple molecules transform into the complex compounds necessary for life. As we look to Titan, we are reminded of the incredible diversity of worlds in our solar system and the profound questions they raise about our origins. What secrets lie hidden in its methane lakes? Could Titan's chemistry hold clues to the universal recipe for life? These are the mysteries Dragonfly aims to unravel, bringing us one step closer to understanding our place in the cosmos. Now turning to the Psyche mission, we shift our focus to a fascinating asteroid that could unlock secrets about the very building blocks of our solar system. Psyche, a metal-rich asteroid orbiting between Mars and Jupiter, is unlike any other object we've studied. Scientists believe it may be the exposed core of an ancient protoplanet, offering a rare glimpse into the violent processes that shaped the early solar system. By exploring Psyche, we could gain unprecedented insights into how planetary cores form and evolve, shedding light on the origins of rocky planets like Earth. What makes Psyche so intriguing is its composition. Unlike most asteroids, which are rocky or icy, Psyche is thought to be made almost entirely of metal, primarily iron and nickel. This unique makeup suggests it could be the remnant of a protoplanet that lost its outer layers through collisions billions of years ago. Studying Psyche's surface and interior could reveal clues about the differentiation of planetary bodies, the process by which dense metals sink to form cores while lighter materials rise to form crusts and mantles. This mission could fundamentally change our understanding of how planets like Earth came to be. The Psyche mission also showcases cutting-edge technology. To reach the asteroid belt, the spacecraft relies on an innovative solar electric propulsion system. This system uses solar panels to capture energy from the sun, which is then converted into electricity to power ion thrusters. These thrusters expel charged particles at incredibly high speeds, providing a steady and efficient push over long distances. This technology not only enables the spacecraft to travel farther, but also reduces the need for large amounts of fuel, making deep space exploration more sustainable. As Psyche embarks on its journey, it carries with it the potential to revolutionize our understanding of planetary formation. What will its metallic surface tell us about the early solar system? Could it hold clues about the violent collisions that shaped our cosmic neighborhood? These are the questions the Psyche mission seeks to answer, bringing us closer to understanding the origins of the worlds around us, and perhaps even our own. Now turning to the deeper implications of the Psyche mission, let's explore how this metallic asteroid could reshape our understanding of planetary formation. Scientists believe Psyche might be the exposed core of a protoplanet that never fully formed, offering a rare window into the early stages of our solar system. By studying its composition, we can learn how dense metals like iron and nickel separated from lighter materials during the differentiation process, a key step in the formation of planets like Earth. This mission could reveal how planetary cores solidify and evolve, providing clues about the internal structure of rocky worlds. One of the most exciting possibilities is that Psyche could hold evidence of the violent collisions that dominated the early solar system. These impacts may have stripped away the outer layers of the protoplanet, leaving behind its metallic core. By analyzing Psyche's surface and interior, scientists hope to piece together the history of these ancient collisions and understand how they influenced the formation of planets and moons. This could help us reconstruct the chaotic environment of the early solar system and explain why some bodies, like Earth, developed thick crusts and mantles, while others, like Psyche, remained as exposed cores. Beyond its scientific value, Psyche also raises intriguing possibilities for resource discovery. Metallic asteroids like Psyche are rich in valuable materials, including iron, nickel, and potentially rare metals like platinum and gold. While the primary goal of the mission is scientific exploration, the data gathered could pave the way for future asteroid mining. Extracting these resources could revolutionize space exploration by providing materials for construction, fuel production, and even life support systems on long-duration missions. However, this also brings up ethical and logistical challenges, such as how to responsibly harvest resources from celestial bodies without disrupting their scientific value. As we continue to unravel the mysteries of Psyche, we're not just learning about the past, we're also shaping the future of space exploration. What secrets does this metallic world hold about the origins of our solar system? Could it inspire new technologies or even a new era of resource utilization in space? These are the questions that drive the Psyche mission, reminding us that every discovery brings us closer to understanding our place in the cosmos. Now turning to the Vera C. Rubin Observatory, let's dive into a mission that promises to transform our understanding of the cosmos on an unprecedented scale. Over the course of 10 years, this groundbreaking observatory will conduct a comprehensive survey of the night sky, mapping billions of galaxies and stars with incredible precision. Its primary goal is to shed light on two of the greatest mysteries in modern science: dark matter and dark energy. Together, these invisible forces make up more than 95% of the universe, yet their true nature remains elusive. By capturing detailed images of the sky and tracking the movement of celestial objects, the Vera C, Rubin Observatory could provide the data needed to unravel these cosmic enigmas. At the heart of this mission is the observatory's cutting-edge technology, including its massive camera, which is one of the largest ever built. This camera will capture high-resolution images of the night sky, allowing scientists to observe faint and distant objects that were previously beyond our reach. The observatory's wide-field telescope will scan the sky repeatedly, creating a dynamic map of the universe that reveals changes over time. This capability is crucial for studying phenomena like supernova, asteroid movements, and even the mysterious behavior of dark energy, which is thought to be driving the accelerated expansion of the universe. One of the most exciting aspects of the Vera C Rubin Observatory is its potential to discover entirely new celestial phenomena. By observing the universe in such detail, scientists may uncover objects or events that challenge our current understanding of physics and cosmology. For example, the observatory could detect rare gravitational lensing events, where the gravity of massive objects bends light from distant galaxies, creating magnified or distorted images. These observations could provide new insights into the distribution of dark matter and the large-scale structure of the universe beyond its scientific discoveries, the Vera Sea. Rubin Observatory will also serve as a powerful tool for education and public engagement. Its vast dataset will be made available to researchers and amateur astronomers around the world, fostering collaboration and inspiring the next generation of scientists. As we look to the future, this mission reminds us that the universe is full of mysteries waiting to be uncovered. What will the Vera Sea, Rubin Observatory reveal about the hidden forces shaping our cosmos? And how will these discoveries reshape our understanding of the universe? These are the questions that drive this ambitious mission, pushing the boundaries of human knowledge and exploration. Now turning to the deeper mysteries of dark matter and dark energy, let's explore how the Vera Sea, Rubin Observatory could unlock secrets that have puzzled scientists for decades. Dark matter and dark energy together make up more than 95% of the universe, yet we know almost nothing about them. Dark matter, which doesn't emit light or energy, reveals its presence only through its gravitational effects on galaxies and galaxy clusters. Dark energy, on the other hand, is the mysterious force driving the accelerated expansion of the universe. Despite their dominance, both remain invisible and enigmatic, leaving scientists with more questions than answers. The Vera Sea, Rubin Observatory's decade-long survey of the night sky, could be the key to unraveling these cosmic puzzles. By mapping the distribution of galaxies and tracking their movements over time, the observatory will provide unprecedented data on how dark matter shapes the universe's large-scale structure. For instance, the way galaxies cluster and move can reveal the presence of dark matter, even though we can't see it directly. Similarly, by observing how the expansion of the universe changes over time, scientists hope to gain insights into the nature of dark energy. Is it a constant force, or does it vary over time? The answers could fundamentally alter our understanding of the cosmos. One of the most promising tools in this quest is gravitational lensing, a phenomenon where the gravity of massive objects like galaxy clusters bends the light from more distant objects. The Vera Sea, Rubin Observatory's ability to detect and analyze these lensing events will provide critical clues about the distribution of dark matter. By studying how light is bent and distorted, scientists can create detailed maps of dark matter's influence, shedding light on its properties and behavior. These maps could also help test theories about the nature of dark matter, such as whether it consists of exotic particles or something entirely different. The implications of solving these mysteries are profound. Understanding dark matter could revolutionize our knowledge of particle physics, potentially leading to the discovery of new particles or forces that go beyond the standard model. Meanwhile, unraveling the secrets of dark energy could reshape our understanding of the universe's fate. Is the universe destined to expand forever, or could dark energy eventually reverse its effects, leading to a cosmic collapse? The answers could redefine not only cosmology but also our place in the universe. As the Vera Sea, Rubin Observatory begins its mission, it carries the potential to transform our understanding of the cosmos. By shedding light on dark matter and dark energy, this groundbreaking observatory could answer some of the most profound questions in science. What will it reveal about the invisible forces shaping our universe, and how will these discoveries change the way we see the cosmos? These are the questions that make this mission so exciting, as it pushes the boundaries of human knowledge and exploration. Now turning to the stars, let's explore the Breakthrough Starshot initiative, a bold and revolutionary mission that could redefine interstellar exploration. This ambitious project aims to send tiny, light-powered probes to the Alpha Centauri star system, our closest stellar neighbor located just over 4 light-years away. What makes this mission so groundbreaking is its use of laser propulsion, a technology that could propel these probes to speeds of up to 20% the speed of light. At such incredible velocities, the journey to Alpha Centauri, which would take tens of thousands of years with conventional spacecraft, could be completed in just a few decades. The concept behind Breakthrough Starshot is as simple as it is ingenious. A powerful array of ground-based lasers would fire a concentrated beam of light at the probes, each equipped with a lightweight sail. The energy from the laser beam would push the sail, accelerating the probes to unprecedented speeds. This method of propulsion eliminates the need for heavy fuel, allowing the probes to be small, lightweight, and cost-effective. Once launched, these probes would carry miniaturized instruments designed to capture images, collect data, and transmit information back to Earth as they fly through the Alpha Centauri system. However, the challenges of such a mission are immense. One of the biggest hurdles is developing the laser technology capable of delivering the necessary power without losing focus over such vast distances. The probes themselves must be incredibly durable, able to withstand the harsh conditions of space, including radiation and micrometeoroid impacts. Communication across interstellar distances is another major challenge. The probes would need to transmit data back to Earth using tiny, low-power transmitters, requiring advanced receivers on Earth to detect their faint signals. Despite these challenges, the potential rewards are extraordinary. Breakthrough Starshot could provide humanity's first close-up look at another star system, offering insights into the planets orbiting Alpha Centauri and their potential habitability. Imagine the possibility of discovering Earth-like worlds or even signs of life beyond our solar system. This mission could also pave the way for future interstellar exploration, proving that humanity is capable of reaching beyond the confines of our own cosmic neighborhood. As we look to the stars, Breakthrough Starshot represents a daring leap into the unknown. It challenges us to think beyond the limits of current technology and imagine a future where the stars are within our reach. What will we discover when we finally send our first probes to another star system? And how will this mission inspire the next generation of explorers? These are the questions that make Breakthrough Starshot one of the most exciting and transformative space missions of our time. Now turning to the challenges of interstellar exploration, the Breakthrough Starshot mission presents a series of technological and logistical hurdles that must be overcome to make this vision a reality. One of the most critical challenges is the development of miniaturized instruments capable of functioning in the harsh environment of space. These instruments must be incredibly small, lightweight, and energy efficient, yet robust enough to collect and transmit valuable data from another star system. Designing such technology requires breakthroughs in materials science, electronics, and engineering, pushing the boundaries of what is currently possible. Another major challenge lies in the laser propulsion system itself. To achieve the necessary speeds, the ground-based laser array must deliver an unprecedented amount of energy with pinpoint accuracy over vast distances. Even the slightest misalignment or loss of focus could render the mission ineffective. Additionally, the probe's light sails must be engineered to withstand the intense laser beam without tearing or degrading, while also being able to navigate through the interstellar medium, which is filled with dust and radiation. These technical demands highlight the complexity of the mission and the need for innovative solutions. Communication across interstellar distances is yet another formidable obstacle. The probes will be traveling billions of miles away from Earth, and their tiny transmitters will have to send data back using extremely low power. To detect these faint signals, Earth-based receivers will need to be highly sensitive and capable of filtering out background noise. This requires advancements in signal processing and the construction of massive receiver arrays, adding another layer of complexity to the mission. Beyond the technical challenges, there are also ethical considerations to address. Sending probes to another star system raises questions about our responsibility as explorers. Could we inadvertently contaminate another world with Earth-based microbes? How do we ensure that our actions do not harm potential extraterrestrial ecosystems? These questions underscore the importance of planetary protection and the need for careful planning as we venture into uncharted territory. Despite these challenges, the potential scientific rewards of breakthrough Starshot are immense. Successfully reaching Alpha Centauri could provide humanity with its first close-up look at another star system, offering insights into the formation and evolution of planets beyond our solar system. The mission could also help us identify potentially habitable worlds, bringing us one step closer to answering the age-old question of whether we are alone in the universe. Moreover, the technologies developed for this mission could have far-reaching applications, from improving space exploration capabilities to advancing communication systems here on Earth. As we push the boundaries of what is possible, breakthrough Starshot reminds us of the power of human ingenuity and the limitless potential of exploration. It challenges us to dream big, to innovate, and to strive for a future where the stars are no longer out of reach. What discoveries await us in the Alpha Centauri system? And how will this mission shape the future of interstellar exploration? These are the questions that drive us forward, inspiring a new era of discovery and wonder. Now turning to the Lunar Gateway, this ambitious project represents a significant leap forward in humanity's efforts to establish a sustainable presence beyond Earth. The Lunar Gateway is a planned space station that will orbit the Moon, serving as a critical staging point for both lunar and deep space missions. Unlike the International Space Station, which orbits Earth, the Gateway will provide a unique vantage point and operational base for exploring the Moon and preparing for missions to Mars and beyond. One of the Gateway's primary roles is to support NASA Artemis Program, which aims to return humans to the Moon and establish a long-term presence there. The Gateway will act as a hub for astronauts traveling to and from the lunar surface, offering a place to live, work, and conduct experiments. It will also serve as a testing ground for new technologies such as advanced life support systems, radiation shielding, and habitat modules, which will be essential for future missions to Mars. By testing these technologies in the lunar environment, scientists and engineers can refine their designs and ensure they are ready for the challenges of deep space exploration. In addition to supporting Artemis missions, the Lunar Gateway will play a crucial role in scientific research. Its position in lunar orbit will allow for unprecedented observations of the Moon's surface, as well as studies of the space environment, including solar radiation and micrometeoroid impact. These insights will not only enhance our understanding of the Moon, but also help us prepare for the harsh conditions of interplanetary travel. The Gateway will also serve as a platform for international collaboration, with contributions from space agencies around the world, including the European Space Agency, the Canadian Space Agency, and the Japan Aerospace Exploration Agency. This global effort underscores the importance of working together to achieve shared goals in space exploration. The Gateway's modular design will allow it to evolve over time, with new components added as needed to support more complex missions. For example, future modules could include laboratories, docking ports for spacecraft, and even facilities for producing fuel and other resources from lunar materials. This adaptability makes the Gateway a cornerstone of sustainable lunar exploration, enabling humanity to build a lasting presence on the Moon and use it as a stepping stone for missions to Mars and beyond. As we look to the future, the Lunar Gateway represents more than just a space station. It symbolizes humanity's collective ambition to explore, discover, and thrive in the cosmos. By creating a permanent outpost in lunar orbit, we are laying the foundation for a new era of space exploration, one that will take us farther than we have ever gone before. What new technologies will we develop? What discoveries will we make? And how will the Gateway shape the future of human spaceflight? These are the questions that drive us forward, inspiring a new generation of explorers to reach for the stars. Now turning to the Gateway's role in deep space exploration. This lunar outpost is more than just a waypoint for moon missions. It's a critical testing ground for the technologies that will take us to Mars and beyond. One of the key challenges of interplanetary travel is ensuring the safety and survival of astronauts in the harsh environment of deep space. The Gateway will allow us to test advanced life support systems, which are essential for maintaining breathable air, clean water, and sustainable living conditions during long-duration missions. These systems will need to operate flawlessly for months or even years, making the Gateway an invaluable proving ground. Another critical technology being tested on the Gateway is radiation shielding. Beyond Earth's protective magnetic field, astronauts are exposed to higher levels of cosmic radiation, which poses significant health risks. The Gateway will serve as a laboratory for developing and refining shielding materials and techniques to protect crews on future missions to Mars. By studying how radiation interacts with different materials in the lunar environment, scientists can design habitats and spacecraft that minimize exposure and keep astronauts safe. The Gateway will also play a pivotal role in testing habitat modules designed for deep space missions. These modules will need to be compact, efficient, and capable of supporting human life for extended periods. Lessons learned from operating these habitats in lunar orbit will directly inform the design of similar structures for Mars missions. Additionally, the Gateway's modular design allows for flexibility, enabling the addition of new components as technology evolves. This adaptability ensures that the Gateway remains at the forefront of space exploration, ready to support increasingly ambitious missions. International collaboration will be a cornerstone of the Gateway's success in deep space exploration. Space agencies from around the world, including the European Space Agency, the Canadian Space Agency, and the Japan Aerospace Exploration Agency, are contributing expertise, technology, and resources to this shared endeavor. This global partnership not only spreads the financial and technical burden, but also fosters innovation by bringing together diverse perspectives and capabilities. By working together, humanity can achieve what no single nation could accomplish alone. As we look ahead, the Lunar Gateway represents a crucial stepping stone in our journey to Mars and beyond. It's a place where we can test the technologies, systems, and strategies that will enable us to explore deeper into the solar system. The Gateway is more than just a space station. It's a symbol of our collective ambition to push the boundaries of human exploration. What new breakthroughs will we achieve? How will these advancements shape the future of space travel? These are the questions that drive us forward, inspiring a new era of discovery and innovation. Now turning to a mission that could one day save our planet, let's explore NAS, a DART mission, a groundbreaking effort to test the first ever planetary defense technique. In September 2022, the DART spacecraft made history by intentionally crashing into an asteroid called Dimorphos, a small moon orbiting a larger asteroid named Didymos. The goal, to see if we could alter the asteroid's trajectory using kinetic impact, and it worked. The collision successfully changed Dimorphos' orbit, proving that humanity has the potential to defend Earth from a catastrophic asteroid impact. This mission wasn't just about hitting a target in space, it was about proving that we could protect our planet from a real threat. Asteroids have shaped the history of Earth, from the extinction of the dinosaurs to the formation of our oceans. While most asteroids pose no danger, a large enough impact could devastate life as we know it. The DART mission showed that we have the technology to nudge an asteroid off course, potentially preventing a disaster. It's a monumental step forward in planetary defense, giving us a tool to safeguard our future. But the implications of DART go beyond just deflecting asteroids. The mission also demonstrated the importance of international collaboration and advanced planning. Scientists and engineers from around the world worked together to track the asteroid, calculate the impact, and measure the results. This kind of teamwork will be essential if we ever face a real asteroid threat. Additionally, DART's success has sparked new interest in developing more advanced deflection techniques, such as using gravity tractors or nuclear devices to redirect larger asteroids. Looking ahead, the lessons learned from DART will shape the future of planetary defense. Missions like this remind us that space isn't just about exploration, it's also about protection. By continuing to study asteroids and refine our deflection strategies, we can ensure that Earth remains safe for generations to come. The DART mission is a testament to human ingenuity and our ability to tackle challenges that once seemed insurmountable. What other threats might we face in the cosmos, and how will we rise to meet them? These are the questions that drive us to keep pushing the boundaries of what's possible. Now turning to the dual potential of asteroid-related missions, let's explore how the same technologies that protect Earth could also unlock vast resources in space. The success of the DART mission not only proved we can defend our planet, but also highlighted the possibility of harnessing asteroids for their valuable materials. Asteroids are rich in rare metals like platinum, gold, and cobalt, as well as water, which could be used to support life and fuel future space missions. By redirecting asteroids, we could one day mine them, turning these celestial bodies into stepping stones for deeper space exploration. The idea of asteroid mining might sound like science fiction, but it's closer to reality than you might think. Technologies developed for planetary defense, such as precise navigation and impact modeling, could be adapted to safely approach and extract resources from asteroids. Water, for example, could be broken down into hydrogen and oxygen to create rocket fuel, enabling spacecraft to refuel in space rather than carrying all their fuel from Earth. This would drastically reduce the cost and complexity of long-distance missions, making Mars and beyond more accessible. However, the prospect of asteroid mining raises significant ethical and legal questions. Who owns the resources in space? The Outer Space Treaty of 1967 states that no nation can claim sovereignty over celestial bodies, but it doesn't clearly address the exploitation of resources by private companies or governments. As interest in asteroid mining grows, the international community will need to establish clear guidelines to prevent conflicts and ensure that space resources are used responsibly and equitably. Another challenge is the environmental impact of mining in space. While asteroids are not inhabited, the process of extracting resources could have unintended consequences, such as altering their orbits or creating debris that could threaten other missions. Balancing the potential benefits of asteroid mining with the need to preserve the integrity of our solar system will be a key consideration as this technology advances. The DART mission has shown us that we have the capability to interact with asteroids in meaningful ways, whether for defense or resource utilization. As we look to the future, the lessons learned from planetary defense could pave the way for a new era of space exploration, where asteroids are not just threats to avoid but opportunities to seize. The question is, how will we navigate the challenges of this new frontier, and what will it mean for humanity's future in space? Now turning to the next frontier of exploration, let's dive into the European Space Agency's JUICE mission, a groundbreaking endeavor set to study Jupiter's icy moons Ganymede, Callisto, and Europa. These moons have long fascinated scientists because of their potential to harbor life, hidden beneath their icy surfaces. The JUICE mission, which stands for Jupiter Icy Moons Explorer, aims to uncover the secrets of these distant worlds, focusing on their subsurface oceans, geological activity, and the conditions that might make them habitable. One of the most exciting aspects of the JUICE mission is its ability to study Ganymede, the largest moon in the solar system and the only one known to have its own magnetic field. This magnetic field interacts with Jupiter's powerful magnetosphere, creating a unique environment that could hold clues about the moon's internal structure and its potential to support life. By analyzing Ganymede's magnetic field and its subsurface ocean, JUICE could provide unprecedented insights into how such environments evolve and whether they could sustain microbial life. The mission will also explore Callisto and Europa, two other icy moons with their own intriguing characteristics. Callisto, with its heavily cratered surface, offers a window into the early solar system, while Europa's smooth, icy crust hides a vast ocean that could be one of the most promising places to search for life beyond Earth. JUICE's advanced suite of instruments, including radar systems, spectrometers, and cameras, will map these moons in detail, studying their surfaces, interiors, and the interactions between their oceans and ice layers. However, operating in Jupiter's intense radiation environment presents significant challenges. Jupiter's magnetosphere is one of the most hostile regions in the solar system, with radiation levels that can damage spacecraft electronics and instruments. To overcome this, the JUICE mission has been designed with robust shielding and radiation-hardened components, ensuring it can withstand the harsh conditions and continue to gather valuable data throughout its mission. The JUICE mission represents a major step forward in our understanding of icy moons and their potential to support life. By studying Ganymede, Callisto, and Europa, this mission could reveal not only the conditions necessary for life, but also how these moons have evolved over billions of years. As we look to the future, the discoveries made by JUICE could reshape our understanding of habitability in the solar system and beyond, opening new possibilities for exploration and the search for extraterrestrial life. Now turning to Ganymede's magnetic field, this unique feature sets it apart from every other moon in the solar system. Unlike its icy siblings, Ganymede generates its own magnetic field, a rare trait that makes it a fascinating subject for scientific study. This magnetic field interacts with Jupiter's immense magnetosphere, creating a dynamic environment that could hold the key to understanding how magnetic fields influence subsurface oceans and potentially habitability. One of the most intriguing aspects of Ganymede's magnetic field is how it interacts with its subsurface ocean. Scientists believe that the moon's ocean, hidden beneath its icy crust, could be in direct contact with the magnetic field. This interaction might create unique chemical processes, such as the production of oxygen or other compounds that could support microbial life. By studying these interactions, the JUICE mission could uncover clues about how life might emerge and thrive in such environments. To explore these phenomena, the JUICE mission is equipped with advanced scientific instruments designed specifically to study Ganymede's magnetic field and its effects. One of the key tools is a magnetometer, which will measure the strength and direction of the magnetic field, providing detailed data on how it interacts with Jupiter's magnetosphere. Another critical instrument is a plasma analyzer, which will study the charged particles surrounding Ganymede, shedding light on how the magnetic field shapes the moon's environment. Additionally, JUICE's radar system will penetrate Ganymede's icy crust, mapping the structure of its subsurface ocean and how it connects to the magnetic field. This data could reveal whether the ocean is in direct contact with the moon's rocky mantle, a scenario that could enhance the potential for chemical reactions necessary for life. By combining these measurements, scientists hope to piece together a comprehensive picture of Ganymede's internal dynamics and its potential to support life. The study of Ganymede's magnetic field is not just about understanding this one moon. It's about unlocking broader insights into how magnetic fields and subsurface oceans interact across the solar system. If Ganymede's ocean proves to be a viable environment for life, it could have profound implications for our search for habitable worlds beyond Earth. As the JUICE mission continues its journey, the data it gathers from Ganymede could reshape our understanding of where and how life might exist in the universe. Now turning to the Nancy Grace Roman Space Telescope, this groundbreaking mission is set to transform our understanding of the universe in ways we can barely imagine. Designed to study dark energy, exoplanets, and the large-scale structure of the cosmos, the Roman Space Telescope will provide an unprecedented view of the universe. Its wide-field imaging capabilities will allow it to capture vast swaths of the sky in incredible detail, offering insights into the mysterious forces driving cosmic expansion and the distribution of galaxies across the universe. One of the most exciting aspects of the Roman Space Telescope is its potential to discover thousands of exoplanets. Using a technique called microlensing, the telescope will detect planets by observing how their gravity bends and magnifies light from distant stars. This method is particularly effective for finding planets that are far from their host stars, including those in the cold, outer regions of their systems. By identifying these distant worlds, the Roman Space Telescope could uncover a treasure trove of exoplanets, many of which may be unlike anything we've seen before. But the mission doesn't stop at discovery. The Roman Space Telescope will also study the atmospheres of these exoplanets, searching for signs of habitability and even potential biosignatures. By analyzing the light that passes through a planet's atmosphere, scientists can determine its composition, temperature, and whether it contains gases like oxygen or methane that could indicate the presence of life. This capability could bring us closer than ever to answering the age-old question: are we alone in the universe? In addition to its exoplanet studies, the Roman Space Telescope will play a crucial role in unraveling the mysteries of dark energy. By mapping the distribution of galaxies and measuring how their light is stretched by the expansion of the universe, the telescope will provide critical data on the nature of dark energy and its influence on cosmic evolution. This could help us understand why the universe is expanding at an accelerating rate and what this means for the future of the cosmos. The Nancy Grace Roman Space Telescope represents a giant leap forward in our quest to understand the universe. With its ability to explore dark energy, discover new worlds, and study their atmospheres, this mission could revolutionize astronomy and bring us closer to answering some of the most profound questions about our place in the cosmos. As we look to the stars, the Roman Space Telescope promises to illuminate the mysteries of the universe like never before. Now turning to the Roman Space Telescope's potential to identify Earth-like exoplanets, this mission could revolutionize our search for life beyond our solar system. By studying the atmospheres of these distant worlds, scientists will look for key indicators of habitability, such as the presence of oxygen, water vapor, or methane. These gases could suggest the existence of environments capable of supporting life as we know it. The telescope's advanced instruments will allow it to analyze the chemical makeup of exoplanet atmospheres with remarkable precision, providing clues about their potential to host living organisms. One of the most exciting possibilities is the discovery of an exoplanet with conditions similar to Earth. Such a find would not only narrow down the search for life, but also provide a prime target for future interstellar missions. Imagine a world with a stable climate, liquid water, and an atmosphere rich in oxygen, a place where life could thrive. The Roman Space Telescope could identify these promising candidates, guiding humanity's efforts to explore and perhaps one day visit these distant worlds. But the implications go beyond just finding habitable planets. Discovering a world with signs of life would fundamentally change our understanding of biology and our place in the universe. It would raise profound questions about the origins of life and whether it is a common occurrence or a rare phenomenon. Are we alone, or is the universe teeming with life? The Roman Space Telescope could bring us closer to answering these questions, reshaping our perspective on existence itself. As we continue to explore the cosmos, the Roman Space Telescope stands as a beacon of hope and discovery. Its ability to identify and study Earth like exoplanets could pave the way for future missions, bringing us one step closer to finding life beyond our solar system. With each new discovery, we inch closer to understanding whether we are truly alone in the universe, or if we are just one of many forms of life scattered across the stars. Now turning to China's Chang'e lunar missions, this ambitious series of missions has already achieved remarkable milestones in lunar exploration. The Chang'e program has successfully landed robotic spacecraft on the Moon, collected samples, and returned them to Earth, a feat that has provided scientists with invaluable insights into the Moon's composition and history. These missions have uncovered new minerals and shed light on the Moon's geological evolution, offering clues about the early solar system and the processes that shaped our celestial neighbor. One of the most significant discoveries from the Chang'e missions is the presence of water ice in the Moon's permanently shadowed regions. This finding has profound implications for future lunar exploration, as water can be used to support human life and produce rocket fuel. By identifying and studying these resources, the Chang'e missions are paving the way for sustainable lunar habitation and deeper space exploration. Looking ahead, China has announced plans to build a lunar research station in collaboration with other nations. This station aims to conduct long-term scientific research, test new technologies, and prepare for future missions to Mars and beyond. The establishment of a permanent presence on the Moon could revolutionize our approach to space exploration, enabling humanity to utilize lunar resources and expand our reach into the solar system. However, these advancements also raise questions about international space competition and collaboration. As China advances its lunar ambitions, other spacefaring nations are accelerating their own programs, leading to a new era of exploration and potential rivalry. The Chang'e missions highlight the growing importance of the Moon as a strategic and scientific frontier, setting the stage for a dynamic and competitive future in space. With each new mission, the Chang'e program brings us closer to unlocking the Moon's secrets and harnessing its potential. As humanity looks to the stars, these missions remind us that the Moon is not just a destination but a stepping stone to the vast possibilities that lie beyond. Now turning to China's plans for a lunar research station, this ambitious project represents a significant leap forward in humanity's quest to establish a sustainable presence on the Moon. The station, envisioned as a collaborative effort with other nations, aims to serve as a hub for scientific research, technological innovation, and resource utilization. By leveraging the Moon's unique environment, scientists hope to conduct experiments that are impossible on Earth, from studying low-gravity effects on human health to testing advanced life support systems for long-term habitation. One of the primary goals of the Lunar Research Station is to harness the Moon's resources, particularly water ice, which can be converted into oxygen for breathing and hydrogen for rocket fuel. This capability could drastically reduce the cost of space exploration by enabling in situ resource utilization, or ISRU, where materials are sourced directly from the Moon rather than transported from Earth. Such advancements would not only support lunar missions, but also serve as a critical stepping stone for future expeditions to Mars and beyond. The station is also expected to play a key role in preparing for human missions to Mars. By testing technologies like radiation shielding, closed-loop life support systems, and sustainable energy solutions, the Lunar Research Station will help address the challenges of deep space exploration. These innovations could pave the way for humanity's first interplanetary journey, making the Moon a proving ground for the technologies that will define our future in space. However, the establishment of a lunar research station also raises important geopolitical questions. As nations collaborate on this endeavor, questions about resource ownership, territorial claims, and international cooperation will come to the forefront. The Moon, once seen as a distant and uninhabitable world, is now emerging as a strategic frontier with immense scientific, economic, and political value. The success of this project will depend not only on technological achievements, but also on the ability of nations to navigate the complexities of space diplomacy. In the broader context, the Lunar Research Station symbolizes a new era of space exploration, one where humanity moves beyond fleeting visits to establish a lasting presence on another celestial body. As we look to the stars, this station reminds us that the Moon is more than a destination. It is a gateway to the boundless possibilities of the cosmos. With each step forward, we are not only unlocking the secrets of the Moon, but also laying the foundation for humanity's future among the stars. Now turning to NASA's Viper rover, this groundbreaking mission is set to explore the Moon's South Pole, a region shrouded in mystery and potential. The Volatile's Investigating Polar Exploration Rover, or Viper, is designed to hunt for water ice, a resource that could revolutionize lunar exploration. By mapping the distribution and concentration of water ice, Viper aims to provide critical data that could support future human missions, enabling the extraction of water for drinking, oxygen for breathing, and hydrogen for rocket fuel. One of the most exciting aspects of the Viper mission is its focus on the Moon's permanently shadowed regions. These areas, which never receive sunlight, are believed to harbor vast deposits of water ice. However, operating in such extreme conditions presents significant challenges. Temperatures in these regions can plummet to hundreds of degrees below zero, and the lack of sunlight makes solar power impossible. To overcome these obstacles, Viper is equipped with advanced instruments, including a drill to collect samples and spectrometers to analyze the composition of the lunar soil. These tools will allow scientists to determine the exact locations and quantities of water ice, paving the way for sustainable lunar exploration. The Viper rover is also designed to operate autonomously, navigating the rugged terrain of the Moon's South Pole with precision. Its ability to traverse steep slopes and avoid obstacles will be crucial for accessing the most promising sites for water ice. By combining mobility with cutting-edge technology, Viper represents a significant step forward in our ability to explore and utilize the Moon's resources. The implications of this mission extend far beyond the Moon. The discovery and utilization of water ice could drastically reduce the cost of space exploration by enabling in situ resource utilization, or ISRU. This means that instead of transporting resources from Earth, future missions could rely on materials found on the Moon, making long-term lunar habitation and deep space exploration more feasible. Viper findings could also inform the design of future missions, including those aimed at establishing a permanent human presence on the Moon. As Viper prepares to embark on its mission, it symbolizes the next chapter in humanity's journey to the stars. By unlocking the secrets of the Moon's South Pole, this rover could provide the resources and knowledge needed to sustain life beyond Earth. With each step, Viper brings us closer to a future where the Moon is not just a destination, but a stepping stone to the boundless possibilities of the cosmos. Now turning to the broader implications of discovering water ice on the Moon, this resource could be a game changer for sustainable lunar exploration. Water is not just essential for life, it's also a critical component for supporting long-term human presence in space. By extracting and utilizing lunar water ice, future missions could produce drinking water, generate oxygen for breathing, and even create hydrogen for rocket fuel. This process, known as in situ resource utilization, or ISRU, would drastically reduce the need to transport these vital resources from Earth, making lunar missions more cost-effective and sustainable. The potential for a lunar economy based on resource extraction is equally exciting. Water ice could serve as the foundation for a self-sustaining lunar infrastructure, enabling the production of fuel and life support systems directly on the Moon. This would not only support human exploration, but also open the door to commercial ventures, such as mining rare minerals or developing technologies for deep space missions. The Moon could become a hub for scientific research, industrial activity, and even tourism, transforming it from a distant destination into a thriving outpost for humanity. However, establishing a lunar economy comes with its own set of challenges. Extracting and processing water ice in the Moon's harsh environment will require advanced technology and significant investment. Ethical considerations, such as the equitable use of lunar resources and the preservation of the Moon's natural state, must also be addressed. International collaboration will be key to ensuring that the benefits of lunar exploration are shared globally and that the Moon's resources are used responsibly. As we look to the future, the discovery of water ice on the Moon represents more than just a scientific breakthrough. It's a stepping stone toward a new era of space exploration, where the Moon serves as a testing ground for technologies and strategies that could one day take us to Mars and beyond. By unlocking the potential of lunar resources, we're not just exploring the Moon, we're laying the groundwork for humanity's expansion into the cosmos. Now turning to the ExoMars Rover, a groundbreaking mission led by the European Space Agency and Roscosmos, this ambitious project is designed to search for signs of past life on Mars. Equipped with advanced drilling and analytical instruments, the rover has the potential to uncover evidence of ancient microbial life buried beneath the Martian surface. Its sophisticated tools are capable of analyzing soil and rock samples at depths never before reached, offering unprecedented insights into the planet's geological and biological history. One of the most exciting aspects of the ExoMars rover is its ability to detect organic molecules and biosignatures that could indicate the presence of past life. By studying these materials, scientists hope to answer one of humanity's most profound questions. Are we alone in the universe? The rover's instruments are specifically designed to distinguish between biological and non-biological origins of these molecules, ensuring that any discoveries are both accurate and scientifically significant. However, the mission is not without its challenges. Landing on Mars is notoriously difficult, with the planet's thin atmosphere and unpredictable terrain posing significant risks. Once on the surface, the rover must navigate harsh conditions, including extreme temperatures, dust storms, and radiation. These obstacles require cutting-edge engineering and robust systems to ensure the rover's survival and success. Despite these challenges, the ExoMars rover represents a monumental step forward in our exploration of Mars. If successful, it could revolutionize our understanding of the red planet, providing clues about its past habitability and the potential for life elsewhere in the solar system. This mission not only advances our scientific knowledge, but also paves the way for future human exploration of Mars, bringing us closer to the day when humans might walk on its surface. As we look ahead, the ExoMars rover reminds us of the incredible potential of international collaboration in space exploration. By combining the expertise and resources of multiple nations, we can tackle the most complex challenges and unlock the mysteries of our solar system. The discoveries made by this mission could reshape our understanding of life, the universe, and our place within it. Now turning to the profound implications of discovering past life on Mars, the ExoMars rover mission could fundamentally alter our understanding of life's origins and its potential existence beyond Earth. If the rover uncovers evidence of ancient microbial life, it would not only confirm that life once thrived on Mars, but also suggest that life may be more common in the universe than we ever imagined. This discovery would challenge our current theories about how life begins and evolves, opening up new avenues of research in astrobiology and planetary science. The philosophical impact of such a discovery would be equally transformative. Finding life on another planet would force us to reconsider humanity's place in the cosmos. Are we unique, or is life a natural outcome of the right conditions? This question has fascinated scientists, philosophers, and thinkers for centuries, and the ExoMars rover could bring us closer to an answer. It would also spark a broader conversation about the nature of life itself, pushing us to redefine what it means to be alive and how we relate to other potential life forms in the universe. However, with this potential breakthrough comes significant ethical considerations. One of the biggest challenges in Mars exploration is the risk of contaminating the planet with Earth-based microbes. Even the most stringent sterilization protocols cannot guarantee that spacecraft are entirely free of microorganisms. If Earth microbes were to survive on Mars, they could interfere with scientific investigations, potentially masking or destroying evidence of native Martian life. This raises critical questions about planetary protection and the responsibility we have to preserve the integrity of other worlds. The need for planetary protection extends beyond scientific curiosity. It touches on our ethical obligations as explorers and stewards of the cosmos. If Mars harbors or once harbored life, do we have the right to alter its environment? How do we balance our desire to explore and colonize other planets with the need to protect their ecosystems? These questions will become increasingly important as we move closer to sending humans to Mars and establishing a presence there. The ExoMars rover mission is not just about uncovering the past, it's about shaping the future of space exploration. By addressing these scientific, philosophical, and ethical challenges, we can ensure that our journey to Mars is conducted with respect for the planet and its potential inhabitants. As we continue to explore the red planet, we must remain mindful of the profound implications of our discoveries and the responsibilities they entail. The search for life on Mars is not just a scientific endeavor, it's a journey that could redefine our understanding of life, the universe, and our place within it. Now turning to the conclusion of our journey through these 15 groundbreaking space missions, it's clear that each one holds the potential to revolutionize our understanding of the universe, technology, and even life itself. From the James Webb Space Telescope peering into the earliest moments of cosmic history to the ExoMars rover searching for signs of past life on the red planet, these missions are not just scientific endeavors, they are stepping stones toward a future where humanity's reach extends far beyond Earth. Together, they paint a picture of a universe brimming with possibilities, waiting to be explored and understood. The collective impact of these missions is profound. They challenge us to rethink what we know about the origins of life, the formation of planets, and the very fabric of the cosmos. They push the boundaries of technology, inspiring innovations that could transform life on Earth and beyond. And perhaps most importantly, they remind us of our shared curiosity and ambition as a species. These missions are not just about discovering new worlds, they are about discovering ourselves and our place in the vast expanse of space. As we look to the future, it's clear that space exploration is more than a scientific pursuit. It's a testament to humanity's enduring spirit of exploration and discovery. Each mission brings us closer to answering age-old questions and uncovering new mysteries that will shape the course of our civilization. But this journey is not just for scientists and engineers, it's for all of us. The discoveries made by these missions belong to everyone, and they invite us all to dream, to wonder, and to imagine what lies beyond the stars. So, as we conclude this exploration of 15 missions that could change everything, let's remember to stay curious. Let's support the incredible work of scientists, engineers, and explorers who are pushing the boundaries of what's possible. And let's continue to imagine the possibilities of what lies beyond our planet. The universe is vast, and our journey has only just begun. What will we discover next? The answer lies in the stars and in our collective determination to reach them. Don't forget to like, subscribe, and hit the notification bell to stay updated on the latest in space exploration. Together, let's keep exploring the wonders of the cosmos.